Okay, so our problem says using the movie candy data, identify the least squares regression line. All right, so we haven't seen that before. Least squares regression line. Your book talks a little bit more about why it's called the least squares regression line. I'm not going to go into that. Know that there are other regression lines possible, but the least squares is the best, and so that's one we use. And it is the one that's given in your regression results. Okay, so we're gonna identify the least squares regression line, which is that y equals b naught plus b1x from the correlation and regression output to the right? This is what we saw on our computer just a minute ago. There were a few more things down here and I excluded them because we don't need them. And this is the line that best models the data. So write the equation below. Okay, so I just really want to emphasize that we are looking at this section right here. Okay, we are going to identify that line. And we're going to fill in the y-intercept. So the y-intercept is our b naught. So let's round it to say 2 decimal places. Okay, so I'll round it to 300.04, and I'll fill that in here for b naught. Okay, and then my slope rounded to 2 decimal places. Again, I'm going to have to use 3 to round, so it'd be 2.83. I'm going to fill that in for my b1 here. Okay. This statistic output I really like because it literally says, this is the y-intercept, b naught. This is the slope, b1, and it really helps you fill this in. Okay, so let's identify the line. First of all, instead of just writing y, again, we really want to write y hat. It's the predicted y. Now, b naught, we said rounded to 2 decimal places, is 300.04. 300.04. And then the slope is positive, so it is plus 2.83 if I round to 2 decimal places. That's my b1 and then times x. Okay, so there, I've written my equation. Now I want to use the regression line in number 2 to predict the number of calories. Remember, that is our y. It's going to be predicted, so it'll be a y hat for a candy with 70 grams of sugar. Okay, so that's telling us to use x equals 70. So let's plug into our equation. We have y hat is equal to 300.04 plus 2.83, parentheses, plug in 70 for x. Okay, so let's see what y hat actually is. Let's plug that in. All right, 300.04 plus 2.83 times 70. And I get 498.14. Okay. 498.14 calories. So I predict for a candy with 70 grams of sugar, it would have 498.14 calories. Okay, so then it says Milk Duds are my favorite movie candy. And I know they were listed on the list before, but that must have been for a smaller serving size because that is not the truth. I looked it up on Google, of course. And it turns out that Milk Duds have 70 grams of sugar, but 595 calories per box. AKA I should not eat the whole box whenever I go to the movies. So our question is, was the prediction from number 2 too high or too low? So Milk Duds have 70 grams of sugar, and our regression equation says that a candy with 70 grams of sugar should have 498 calories. 498 calories is not as high as 595 is the truth. So again, this is my prediction. And then I have over here the true x value. Okay, I'm sorry, true y value. So predicted versus the actual. So was the prediction too high or too low? This is too low, right? It's lower than the actual. And then how far off was it? So let's subtract. We're going to do, now it says prediction, how far off. It's tempting to do prediction minus the actual, but remember we talked about up here, we always do actual minus predicted. So that's what I'm going to do here. Oops, my actual is 595 minus, let's see, what was it? 498. I'm going to round to just 498. So let's see, 595 minus 498. And get 97. So it was 97 calories too low. Okay. All right, so number 4 says predict the calories in a movie candy with 200 grams of sugar. So hopefully you're kind of starting to see what we do here. Look back up our equation and plug in, instead of 70 this time, x is equal to 200. All right, so let's try it. Y hat is equal to, looking back up on my equation, 300.04 plus 2.83. This time for x, I plug in 200. Let's see what we get. All right, in my calculator, I'm just going to use the arrows to go up and select that previous equation I typed in, 300.04 plus 2.83, but replace the 70 with 200. Oops, I don't need that last little thing. Enter. All right, 866.04 calories. Wow, that's a lot. That's a lot of sugar, so that makes sense. 866.04 calories. Okay, and then the second part of this question says, would you trust this prediction more or less than the prediction you made in number 2? Well, I'm going to flip back over to my scatter plot again here. 200 calories is not even on this scale. None of the sample data had, or sorry, I should have said 200 grams of sugar. It's not on the scale. None of the sample data had anything near 200 grams of sugar in them. So really, I should only be predicting in this range of sugars, okay? 200 is much farther out. Now 70 is within my range, so it's fair to predict with 70, but 200 would be like way out here. That is not a fair value to be predicting with. Or maybe it's not that it's not fair, I just don't expect my results to be very good, okay? So would I trust this prediction more or less than the prediction I made in number 2? Definitely less. Because 200 grams is outside of the interval of sugar amounts in the sample data. Okay. All right. So finally, number 5 says, what is the y-intercept of the equation of the regression line, and interpret that y-intercept. Okay, so this is where we're going to use our sentence from up above. So the y-intercept, B naught, looking at our regression results over here, is a 300.04. So 300.04 answers the first part, and let's interpret that. So we have to say whenever x equals 0 in context. Okay, so remember that x is sugar, so I'm going to say whenever a candy, that's my context, has 0 grams of sugar. Okay, I put x equals 0 in context. So when a candy has 0 grams of sugar, do I know for sure what the calories are going to be? No, I'm making a prediction based on this y-intercept. So be really careful. I'm even going to put it in red because it's so important. The predicted, okay? So that was from my sentence up here again. Whenever x equals 0 in context, the predicted, now let's use the y context. So the predicted number of calories in the candy is whatever the y-intercept is. So is that 300.04 calories. Oh, okay, so our regression line says even if the candy has 0 grams of sugar, we still expect it to have, notice I said expect it to have 300 calories. Okay, so that's my prediction. And then number 6 says, what is the slope of the equation of the regression line, and interpret it. So interpret, again, in case we aren't clear on that, means that you need to write out a sentence putting it in context and explaining what it means. So the slope, looking at that regression result, is 2.83. So 2.83, that answers this first part of the question, and now let's interpret it. So we say with each additional x context. That's one way to put it. I could also say for every additional, right? Some way of saying increasing the x context. by 1 unit. So I'm going to say for every additional, now let's see, what was the X context? Sugar, right, in grams. So for every additional gram of sugar in a candy, the predicted Y context, okay, so the predicted, what was the Y context? It's calories, right? The predicted number of calories increases or decreases by the slope. Well, the slope in this case is a positive 2.83, so we're going to say increases. Increases by 2.83 calories. Can't stay still. All right, done. We've interpreted. Now, just to make that really clear that that's actually what's happening, we just did a prediction for 70 grams of sugar, right? And we got that it was 498. Let's now do a prediction for 71 grams of sugar and see how many more calories it is. So 300.04 plus 2.83 times, this time 71 grams of sugar. 500.97. What's the difference between 500.97 and 498.14? 2.83 calories. So if I increase my gram of sugar by 1 from 70 to 71, then my calories is increased by 2.83 calories. Okay. All right. So that is how we interpret our y-intercept and our slope. There are a few things that we need to add to these problems that we just didn't quite do thoroughly. It's kind of, I tried to write this out like I think you would the first time you think of it, but now I need you to extend that. And so remember that y hat is the predicted y. That's super important, okay? Y hat is the predicted y. But we want to be able to write our equations in context. So instead of writing y hat, we'll replace y with what it represents, which is calories. So we will say calories hat. And I know it kind of looks funny, this really wide hat, but that's how we do it. Calories hat is equal to 300.04 plus 2.83, and then we put our x in context. And in this case, it's 2.83 times sugar. And of course, that's in grams, okay? So I replaced x and y hat with their actual context, which is their actual variable name. Okay, so that means when I'm doing number 2, instead of saying y hat equals, I should say calories hat here was equal to 498 calories. Okay, the predicted calories are 498 calories. All right, so then in number 3, we did this residual equals actual minus predicted. So I just really want to point this out. We actually calculated a residual here. It was the actual minus the predicted. Actual minus the predicted. Okay, and then my residual ended up being 97. So whenever we interpret that, we really want to put it again in context. So we're going to say the actual, and again, use my y context. So the actual number of calories was whatever the residual is, and the residual is 97, so was 97 lower, I guess I should say 97 calories lower. Oh, wait a second. I think I got that confused, and it's really easy to do, so let's get this right. Which one is higher, the actual or the predicted? The predicted. I'm sorry, the actual. The actual is higher. So I should say the actual number of calories was 97 calories higher. Actual is higher than the predicted, or than predicted. and predicted for the X value that we had, X equals whatever, we used 70 grams of sugar. So for 70 grams of sugar. Okay, I didn't have to say anything about X. I just put the X value in context and gave the value that I plugged in there. So I'm kind of glad I actually made this mistake about lower and higher because it's really easy to do. You have to be really careful. The actual was higher than the predicted, and our residual was positive. So positive matches with higher if you put this sentence in this order. Okay, next thing to talk about. Number 4 is about extrapolation, right? I remember I told you that we would come back to it. Be careful of extrapolation. Well, here it is. This is extrapolation. Because this prediction is based on an X value that is outside of the interval of the sample data, okay? So this is extrapolation. We don't want to do extrapolation. It is often not a very good prediction. Okay, so then number 5 was about the y-intercept. So one other thing I want to point out is that if I have the point for the y-intercept, it's 0 for x, and then the value for y-intercept is the value for y in the point. Okay, so I put that in here, 0 for x and predicted y-intercept for y. Finally, I want, instead of saying for every additional gram of sugar, you can also phrase that as when x, sorry, I shouldn't say you can phrase it, but one way to think about it is when x increases by 1. Now, we're not going to use x, right? That's why we phrase it in this kind of more user-friendly language, but that's what it's meaning in terms of our equation. X is increasing by 1. Remember I showed you how whenever I increased from 70 to 71, I increased the sugar by 1. The predicted number of calories actually increased by that number of the slope. Okay, so I think that it for numbers 1 through 6. We're going to do the check your understanding on the next page.